Hi children, welcome to my YouTube channel. This is the first video of the topic series Normal Distribution. What is a normal distribution? The normal distribution is a probability function that describes how the value of the variables are distributed. It is a symmetrical distribution where the most of the observations cluster around the central peak and the probabilities for the values further away from the mean taper off equally in both directions. So if you are concerned about this normal distribution, you can see it's a symmetrical shape as shown over here. And here, if you get the value over here, that would be the mean value for this kind of a distribution. And we can see around the mean, the information distributed symmetrically. For such situations, to find the probabilities of certain events, we can use the normal distribution. Before we learn much about normal distribution, we have to learn about the properties of a normal distribution. The first fact, as I mentioned in the previous slide, is normal distribution is a symmetrical curve around the mean. Here the value is mean. If you work out the other facts of median and the mode even, it would be exactly similar to mean or mean value over here. Right? That's the first property we have to understand. And you can see, if you want to find the probability using this normal distribution, we have to work out the area over here. This area indicates you the probability of the event. If you come across the area over here, that is, you can see this is the area below A. Therefore, if you calculate the area over here, that would be the probability of X is less than A, or it is equals to less than or equals to A. There is no difference between less than A or less than or equals to A for a continuous distribution. Later on, we learn this fact in detail, right? If you come across this area, you can say that is the area above x1, more than x1. So if you calculate the area over here, that is similar to the probability of x is greater than x1. That is the second property we have to understand about normal distribution, right? Then the next fact, if you calculate the total area over here, that probability is a total probability that is equivalent to 1. And as I mentioned in the previous diagram, this is a symmetrical shape. Therefore, if you calculate the area of this bit, that is how much? That would be the half of 1. So if you calculate this area, that would be 0.5. And if you calculate this area, that would be 0.5 itself. Those are the properties we have to understand about the normal distribution. And this is another exceptional theory we have to understand. So when you are working out with the mean, you can understand that this is the mean value over here. And if you calculate one standard deviation to the lower side and upper side from mean, in a normal distribution, there are 68% of information stagnate over here. That means from one standard deviation to the upper side and one standard deviation to the lower side, there would be 68% of information. Or if you tell in another way, from mean, if you get one standard deviation to the upper side, there are 34%, approximately 34% information would be stagnant over here. Then for the lower side, one standard deviation from mean, there would be 34% of information, right? Then if you go ahead with two standard deviation to the upper side and to the lower side, so there would be, if you work out, you will understand that there would be 95% of information will be stagnant. So if you add up 34.13 plus 13.59 plus 34.13 plus 13.59, it would be approximately similar to 95% of the information. Similarly, if you calculate from mean, standard deviations. From mean, 3 standard deviation to the lower side and to the upper side, there would be 99% information will be stagnant over here. That is a basic property where we have to understand from this normal distribution graph. If I just mention, if you calculate the area from one standard deviation to the positive side and to the negative side, there would be 68% information. If you calculate 2 standard deviation to the positive side and to the negative side, there would be 95% of information. Then if you calculate 3 standard deviation to the positive side and to the negative side, there would be 99% of information will be stagnant over there. Right. Then before we learn about the the normal distribution, we have to understand about the notation, right? So when you are working out with the normal distribution, we have to concern about the mean value and the standard deviation of that distribution. So if the mean value is mu and the standard deviation is sigma, we can say X is having a normal distribution of mean mu and standard deviation of sigma square. Sorry, the variance of sigma squared, or that means standard deviation sigma squared. So that is the distribution. That means this is a normal distribution with mean mu and standard deviation of sigma. Right. If you come across this question, the diameter of a metal pin produced by a particular machine X millimeters are modeled as normal distribution of mean 8 and standard deviation of 0.2, right? Find the probability of X is greater than 8. We know that this is more than mu, more than mean. So you know that it's a symmetrical shape from mean value. So these two areas are similar. We know that the total area is 1. Therefore, this should be the half of 1. So what would be this area? This area would be turned up into 0.5. So you can say probability of X is greater than 8 should be 0.5, right? Then we need to find out the probability in between 8.2 to 7.8. We know that here the standard deviation is 0.2. That means from 8, one standard deviation to positive side and one standard deviation to negative side. What is that value? Over here we know that one standard deviation to the positive side and one standard deviation to the negative side would be 68%. That means as a decimal it should be 0.68. Therefore this probability would be 0.68. You have to understand here the gap is 0.2, which is exactly similar to one standard deviation from mean towards negative side, towards positive side and towards negative side. One standard deviation would be there are 0.68 probability of information, or 68% of information will be stagnant over here. Therefore this answer should be 0.68. If you come up with this question, the length X millimeters of a ball produced by a particular machine are normal distributed with mean 35 and standard deviation of 0.4. Sketch the distribution of X. So if you work out, symmetrical line is 35. Then if you work out one standard deviation, 35.4, that is 35 plus 0.4, and less than 0.4 to the from 35, that is 34.6. In this area there would be 68% of information. If you go ahead with two standard deviation, that is 35 plus 0.4 into 2, that is 35.8. To the negative side, 35 minus 0.8 would be 34.8. Here there should be how much of an area? The area must be 95%, and three standard deviation for the positive side and negative side, there would be totally, you can understand that 99% or sometimes more than 99% will be distributed over here. That is the rough sketch of drawing the normal distribution for given information, right? The next case, the distribution of income in dollars per year, $1,000 per year of employees at a bank is shown in right. State with reasons why the normal distribution is not suitable model for this data. So obviously we know that normal distribution can be applied for a symmetrical data. This is not a symmetrical data, it's a skewed data. For a skewed data, we know that we cannot apply the normal distribution. Next case. An arm span of a group of 5-year students, X centimeters, are modeled as normal distribution of mean 120 and standard deviation of 4. This is variance. So you have to understand that standard deviation is 4. Then if you work out over here, this is the mean. This is a symmetrical line. From mean, one standard deviation to positive is 124. One standard deviation to lower side is 116, 120 plus 4, 120 minus 4. In this area, there would be 68% information should be there. Two standard deviation. It's 120 plus 2 into 4, 120 minus 2 into 4, 112 to 120. There are 95% information should be stagnant over here. Then they ask about state the proportion of the student those in the arm span between 160 to 124. That is, this is from mean one standard deviation. There should be 68% or 0.68 as a probability. Then 112 to 128. Two standard deviation to positive and two standard deviation to negative. That means there should be 95% of information should be stagnant in that area. Right. The length of a group of snakes y centimeters are modeled by y equals to normal distribution of 100 sigma squared. If 68% of snakes between 93 to 107, what is 68%? That is one standard deviation from negative to positive. 100 plus sigma is 107. 100 minus sigma is 93. Then what would be the value for sigma? Obviously, we know that sigma should be 7. From there, you can now get the answer. This is 107 squared. Normal distribution of 107 squared. Or other than that, mean 100 and standard deviation of 7. The mass of sheep, m kilograms on a farm are modeled as m. M is having a normal distribution of mean mu and standard deviation of sigma squared. If 85% of sheep weight more than 52 kilograms. So here it's 84% of information. So that is, we know that if you work out, this portion is 16%. If this more, if there are 84%, more than that value means this is 16% less than that. Let's go ahead with this distribution. Yes. Then if you come across this bit, so you can see in this middle range, this is 68% over here in this range. That means on the other side is 100 minus 64, that is 32. That means this each region would be 32 divided by 16. If I repeat it back, in this area that is 68%. That means in this two area there would be 100 minus 68. 100 minus 68 is how much, children? That is turned up to 32. Then each region, so both areas should be 32. That blue color and the green color one. Both areas should be 32. So therefore should be the each side would be 32 divided by, that is 16. That means obviously we can understand from this question, this value is one standard deviation from mu. This value is 52. That is x. That if this portion is 16 means we know that 16 comes to single side at a value of what? At a value of mu minus sigma. Then we can say that this value, here the value is mu minus sigma equals to 52. Then the next one, 47.5 kilograms, they are in 97.5. If this value is 97.5, we know that that is 2.5. To which, that means if you get 2.5 for each side, what is that figure? So if you come across this diagram, you can understand that over here only you can see 2.5%. Here, that is the boundary here is mu minus 2 sigma. Therewith that you can say, mu minus 2 sigma equals to 47.5. Then you get the first equation as mu minus sigma is 52 and mu minus 2 sigma is 47.5. Therefore, you can find out the values of mu and sigma like this. So you will obtain the answer as the mu value. You can obtain the so you can say 47.5 is equal to mu minus 2 sigma, and sigma should be turned up to 4.5 kilograms, and sigma squared is 2.25, and mu value turn up to 56.5. So you have to simplify. Mu minus sigma equals to 52 and mu minus 2 sigma equals to 47.5 as simultaneous equation to obtain the final answer. Right. If you come up with this question, the percentage scores S of a group of students in test are modeled as normal distribution. The mean is 45 and standard deviation of 50. So mean is 45 over here. Then one standard deviation is 45 plus 15, 60. One standard deviation on the negative side is 45 minus 15 is 30. So this portion is 34 and this portion is 34. So you can get this answer from that. Then two standard deviation. So if you work out from here to his 95%, out of 95%, if you divide, that is how much? That is turn up to 47.5%. So if this portion is 34, this value should be obviously 13.5. And the last part would be 2.5 to the each side. Those are the facts where you can, if you're not clear with that, you just work out this proportion and you can, from here you can understand those facts, right? Then if you come up with this. So the first question, since, right, with mean this much, find the probability of S is greater than 45. Which one? That is this portion. Obviously, this should be 0.5, half of 1. In between 30 to 60, 30 to 16, one standard deviation for the both side, that is around 0.68. Then 15 to 75, 15 to 75 is two standard deviation from mean, that should be 0.95, or other than that 95%. XLI is incorrect. So what the next question is, XLI state that the since it's impossible to score about 100%, this is not a suitable model. State with reason whether or not XLI is correct. So you can say this, obviously this is incorrect. The reason is that the probability of X is greater than 100. It's obviously less than 0, or you can see there's a mild probability for more than 100 even, right? So this is considerably very narrow figure. Therefore, you cannot say, you can say that XLR state that it's impossible to score about 100. Obviously, there would be kind of a proportion for more than 100. There, then you can understand that this XLR statement is correct, because there's a very mild area maybe occurs up to infinity, right? Then the next one is standard normal. The standard normal is, we use the standard normal for the convenience of the calculations. General idea of the standard normal is it's a distribution with mean 0 and standard deviation of 1. If I show you one example for standard normal is this. So you can say mean is 0, one standard deviation to positive and negative, two standard deviation to positive and negative. So this is an example for a standard normal distribution, right? Right. So the notation is, it's a normal distribution. It means 0 and standard deviation of 1, right? Now, this is the normal distribution table. We use this table to calculate the probability and probability related questions hereafter. We should learn how to read this table to understand or to obtain a probability for a given event, or when the probability is given, we should be able to identify the relative event, right? So in this table, the first column indicates you the event, and the second column indicates you the probability. Probability, so which probability it's indicate? Always this probability indicates you the probability less than the value given over here, right? If I come across this value, if I want to find probability of X is less than 54, you can go hit here and see whether what is the value. The probability of X is less than 0.4 for a normal distribution of mean 0 and standard deviation of 1 would be 0.7054. So there is no difference between these two if they have given greater or greater than, sorry, less or less than equal or greater than equal, doesn't make a difference. Later on in our statistics too, we will learn some distribution called a continuous distribution. You will understand that fact clearly over there. For the moment, you have to remember whether it's given less than or equals to, it doesn't make a difference for uniform, or sorry, for a continuous distribution, right? Then if I read out this value, what is this figure? This 0.5120 stands for, that is the probability of X is greater than 0.03, right? Now let's see how to read out this table, right? The first case is use the normal distribution table to find the value for probability of x is less than 1.54, right? Okay. Then if I want to read 1.54, so less than that. So the probability it reads as 1.54. So you can go ahead with 1.54 in this table. So what is that value? 0.9382. So there are more information below than that. So just is a part of a graph. So say 1.54 is 0.9382. So obviously we know that this table indicates you the lesser probability. Always this table indicates you the lesser probability. Right. If I read a 1.54, that is probability of x is less than 1.54. Right. So straightforward, you can read it and you can obtain the answer 0.9382. The next case is probability of z is greater than 2.65. Right. Then in the table, just let's see, it's not here, it's some kind of a below than this. If you read out 2.65, you will obtain the answer. The probability of z is less than 2.65. If you read out 2.65 on your normal distribution table, that gives you the probability of z is less than 2.65. But the probability what you need is how much? That is z is greater than 2.65. Then how do you get it? We know that the total area over here is how much? That is obviously 1. We already got from the first information in this slides, right? So if the total area is 1 and if this less than area is 0.99, is the value what you get for 2.65, you just refer your table. Then you can say the greater region. If you want to get the greater region, what you need to do? The total area is 1. Out of 1, if you remove 0.996, you will obtain the answer for the probability of Z is greater than 2.65, right? Then the next fact is, what you need to get is, we can say probability of Z is less than minus 0.75. If you refer to this table, there are no events called minus values. Then what you need to do? So you know that as I mentioned you at the beginning of this theories of this normal distribution, that is, this graph is a symmetrical graph. Then 0 over here, then minus 0.75 is over here. Then if you read out 0.75, you know that if I read the 0.75 from here, sorry, it's from here, this area and this area would be similar. Then if I calculate the part 0.75 from here, you can obtain the answer for this part as well. But if you read 0.75 from here, you'll be getting the other area, not the greater area over here. We will obtain the lesser area. Then how do you get this greater area by reading 0.75? You know that the total area is 1. Out of this total area, if you subtract the 0.75 below than this area, you will obtain the area over here. Then this is probability of Z is less than minus 0.75. That is similar to probability of Z is greater than 0.75. That comes with, if you draw 0.75 over here, these two areas are similar. Then how do you get this area? You can say 1 minus probability of Z is less than 0.75. That means if you read out 0.75, let's see whether it's there. Yes, hopefully, you know, it's not, yeah, it's somewhere here because it's not visible because it's a part of a table. Anyway, you just read 0.75 from your table. That would be 0.7734. Then 1 minus 0.7734, you'll be obtaining the answer 0.2266. That would be the area relative for this, which is similar to the area over here, right? Then if you want to get the probability of Z is less than 1.4 and less than minus 1.2, they are referring to this area, 1.4 to minus 1.2. Then what you're supposed to do? Initially, I'll get the area over here, the total area, that is this bit. Out of this area, if you subtract this bit of it, you will obtain the required area over here. How do you get this area? You can straightforward, you can read probability of Z is less than 1.4. Out of that, you have to subtract minus this bit. Then 1.4, you can read it straightforward. Minus 1.2, you cannot read it. Then if you get a minus value, what you need to do? You have to work out the similar area to that. So that is turn up to if you work out, you can say probability of visit is minus 1.2. You can write that is probability of visit is greater than 1.2. That value is similar to 1 minus probability of visit is less than 1.2. With that, you can obtain the answer 1 minus 0.8849. Then you can obtain the answer in between would be 0.9192 minus the value over here, that is 0.1151. You will obtain the final answer as 0.8401. Right. Then if you want to get this one, right, this is another example, right? Use the normal distribution table to find the following. Z is greater than 1.27. Then Z is greater than, we need this area. But if you read 1.27 from your table, you will be obtaining this area. That area is how much? That is 0.8980. If you want to get the greater area, what you need to do? We know that the total area is 1. So you can say 1 minus probability of Z is less than 1.27. That is turn up to 0.102. This value you can obtain from the diagram over here. If you come across this, Z is greater than minus 1.66. Again, that is this area. So we can work out with this greater area, this area. How do you get that area? Sorry, Z is greater than 1. Sorry, the area is this bit. This is the area what you need to find it. This area would be similar to the area over here. From minus 1.6 and you can get this 1.66. So this area would be similar to this area. How do you get this area? Obviously we can see, we can read the probability of 1.66 straightforward. 0.9515. That is its total area, which is literally similar to the area over here. Therefore, you can get the probability of Z is greater than minus 1.66 would be 0.9515. Right. If I want to get probability of Z is less than minus 2.28, that is this bit. This is literally similar to the positive side, 2.28 this bit. But if you read 2.28 from your table, you will obtain this area. But the required area is this bit. Then how do you get it? You have to subtract 1 minus this bit. 1 minus of this area. That is 0.9887. How do you get this value? If you read 2.28, this value, that is similar to the area over here, less than 2.28. 1 minus that would be the 0.0113. You can obtain the answer over there, right? The next concept, we need to find the probability of Z is in between 0 to 1.31. That is this in between area. Then what you need to do? Then if you want to get this area, first I will find out the probability of Z is less than 1.31. That is this total area. That area is 0.9049. You just read 1.31 from your table, right? Then we want to get the probability of, then you have to remove this bit. But in this area, this is probability of Z is less than 0. That is 0.5. You can refer with your table. 1.31, if you read 1.31, you'll be getting this total area. If you read 0, you'll be getting this area. If you want to get this intermediate area, so you have to subtract 0.5 out of 0.9049 and you can obtain the answer as 0.4049. The next question is probability of Z is in between 1.3 to 1.89. That is, if you read 1.89, you can obtain this area. Not a problem at all. If you read 1.3, you can obtain this area. Then how do you get this intermediate area? Out of the area below 1.89, you have to subtract the area below 1.3. Then you'll be getting the intermediate area over here. Right. The next case is we need to find the probability of Z is in between minus 1.6 to minus 2.8. That is this bit of it. Sorry, this bit of the area. We know that literally we cannot identify the negative areas from your table because table does not support. If you just refer back to these tables, the table is containing for the positive events, not for the negative events. Therefore, we need to identify some fact which is related with the positive region similar to this. We know that this region is similar to the area over here. Then how do you get this area? Then if you get the probability less than 2.8, that is this area. Out of that, if you remove the area less than 1.6, you can obviously get the area in between. Less than 2.8 is 0.9974 and less than 1.6 is 0.9452. With that, you can obtain the intermediate area 0.0522, right? Then, in this example, we need to find the probability of Z is less than 2.12. Obviously, if you what you need to get here is you need to find the value less than 2.12. So you can literally get this answer 0.9299. Let's see whether it's there in the first table. The value is 2.12. If you just refer to 2.12, it's 9830. So that is a probability of Z is less than 2.12, that is 98299, or literally. So it's similar to 0.9830, correct to 4 decimal points. If you want to get Z is less than 1.36, if you read 1.36, you can get the answer that is similar to that value. Then if you want to get probability of Z is greater than 0.84, if you read 0.84, you'll be getting the lesser region, this area. That is the value 0.7995. But if you read the greater area, what you need to do? Total area is 1 minus this answer. You can obtain the answer for this bit. So you can obtain the answer 0.20045 from that. Right. The next case is we need to find the probability of Z is less than minus 0.38. So it's minus 0.38 so you can straightforward, you cannot get it. So you can make them into the positive region, that is probability of Z is greater than 0.38. Then you can say 1 minus probability of Z is less than 0.38. You can obtain the answer over here. If you want to get this one also same thing. If you want to get probability of Z is less than minus 1.63, you can obtain the answer. This is similar to Z is greater than 1.63. That is literally 1 minus probability of Z is less than 1.63. Then you can obtain the answer over here. Right. The next part is probability of Z is in between 0 to minus 2.3. That is this area. If you want to get that area, what you can say? If you want, you can find it is from 0 to 2.3, this bit of it. Similarly, minus 2.3 plus 2.3, that area. So if you want to get this area, what you need to do? You can say that is probability of Z is less than 2.3 minus probability of Z is less than or equals to 0. With that, you can get, because it's another way of getting that answer. So you just find out the similar area over here, 2.3. Then get the probability of Z is less than 2.3 minus probability of Z is less than 0. You can obtain the same answer over here. The next one is we need to find the probability of Z is in between minus 2.16 to 0.85. That is this area. There's a similar area 0.85 to 2.16. This is in between. If you want to get that area, what do you need to do? You can subtract probability of Z is less than 2.16. You just draw 0.85 and 2.16. If you read 2.16, this total area would be count below 2.16. Then if you subtract 0.18 out of that, you'll be getting this area. Then if you subtract the probability of Z is less than 0.85 out of the probability of Z is less than 2.16, you can obtain the answer over here. So you can use the same technique what we have used in this example to do this question as well, right? With that is another technique they have used, but you can use that preliminary technique what they have used over here to obtain the answer for this question as well, right? Okay. If you come up with this, right? Then the next part is we need to identify, find the value of the constant A such that probability of Z is less than A is 0.7517. If you happen to find this value, this is Z is less than A. This bit. What you need to do is you can straightforward see with the value for 0.7513. So if you go ahead with this one, 7513. So if you work out 7513. So you can go ahead with some kind of a closer figure, 0.68. Maybe that is much closer figure for this. Yeah, here. 0.7517. It's over here, sorry. If you read out 7517, that is 0.68. Obviously, The event over here is 0.68. Up to here, we have already learned to if the event is given, how to find the probability. Now, the probability is given, you have to find the event. You are using the reverse process. See with 7517 and you can identify the element, right? The next question is find the value of the constant a such that probability of z is greater than a equals to 0.1. So there is a small table in the next page after the probability distribution. Here, you see there are some kind of rare probabilities with their relative event. This indicates you the greater side, not the lesser side. In the first page of the normal distribution says the lesser side, but here they mention the greater side. From 0.1, if you read this event, 0.1 to a16, then the answer should be 0.2816, right? Then if you come up over here, find the event for given probability. So we need one probability Z is greater than 0.322. Then we know that lesser region is 0.322, greater region is 0.322, but from the table it shows you the lesser region. Then to get the lesser region relative for this event, we can get 1 minus 0.0322. That is 0.9678. Then read the 0.9678 from your table. If you read it, you will obtain the answer as 1.85. Therefore, the A value should be 1.85. If you come up with this. So you can say probability of Z is less than 1075. I don't think that 0.1075 is too small. That means it's in the negative side. If you get a very small probability less than 0.5, you can say it's in the negative side from the normal distribution. Then to find that answer, subtract this answer from 1 and read it from the table and put a negative in front of that. That's a simple technique of doing. If you get a negative region and if you get a very small value, what you need to do is you just subtract this value from 1. Then read the Z value for that, 0.8925. So if you read out 0.8925, see, let's see whether it's in the below part of the table because it's just a part of the table. That is, if you read out, that is 8925 would be 1.24. Then you have to put a minus in front of it. That would be the answer for this question, right? If you come across over here, less than equals to 0.75. Now from the table, you can this less than region, see whether what is the value relative for 0.75. That is, we can like if you go ahead with this 0.75, 7,500. That is, you can say that the two value there, it's in between some kind of two values. So you can go ahead with the closer figure. I will choose 1.67 as the answer for this question, right? So that's how you need to do it. So this is the basic idea of working out the normal distribution. We will try to understand how to use this normal distribution in our practical life experiments and with the outcomes where you observe over there, right? So we basically in this topic we have what we have already learned is what is a normal distribution and how to find the probability for a given event and how to find the event when the probability is given.